last set of exposure calculations here. Pretty easy. You can see we've kind of got a ratio set up. If you're looking here, we've got, just looking over there, we've got milliamp 1, milliamp 2, source to film distance 1, source to film distance 2. Okay? Time 1, time 2, source to film, okay, both 1 and 2 squared. Combining the two, milliamp 1, time 1. Milliamp 2, time 2, source film distance 1 squared, source film distance 2 squared. Alright. Reason these are called exposure calculations is this. If you have a 10 milliamp minute exposure, okay, and exposure is referred to as milliamp minutes or milliamp seconds. If you have a 10 milliamp minute exposure, you could do that with 1 milliamp, 10 minutes. Okay? 10 milliamp minute exposure. 2 milliamps, 5 minutes. Okay, 3 milliamps, so on and so forth, all the way down. Okay, where you get down to 10 milliamps, 1 minute. Okay? So, something to think about there. That's just how you make an exposure. Nothing too terribly difficult, just something to keep in mind. Alright, so now we're going to combine these exposures, milliamp time, to make a milliamp and time combined over here, a general overall exposure to say this. If this is your X-ray tube, okay, got a little window in here, inside of here is all the inner workings, all that good stuff. Cone of radiation coming down. If we were measuring from this source to our film distance, okay, we'd say, alright, for this first one here, we have a source to film distance of 18 inches squared to start with, and then we're going to move that down, trying to keep the same exposure to 24 inches. I guess I should get rid of the squared. To 24 inches. We want to know how long it's going to take to get this same shot moving the film down farther away. Okay? So we come up here, we're going to cross multiply. We're going to say 5 times 24 squared equals whatever. Okay, so 5 times 24 squared looks like 2880. So this times this divided by this. Alright, now we're going to divide that by 18 squared. That brings us down to 8.88 something. Okay, we round it off, that's good enough. We've got milliamp 1, milliamp 2. So if this is 8.88, it's got to be milliamps. Okay? So, what we would say here is this. If we had an original exposure of 5 milliamps, okay, we're going to a 24-inch source to film distance. We were at an 18-inch source to film distance. So if we were here and we're going farther away, it's going to take longer to get that same exposure. Okay? Simple enough there. This guy over here for time works the same way. 10 times 20 squared. Okay? As you can see, they're all set up the same. This is milliamps, this is time. Doesn't make a difference. It just means you're changing one and keeping the other the same. It doesn't make a difference until we get over here in milliamp and time combined. So, 10 times 20 squared equals whatever divided by 27 squared. Okay, that should give us something. So, 10 times 20 squared, push the right buttons here. That's 4,000 divided by 27 squared is 5.49 once you round that up, and that is going to be in minutes. Okay, it's time. Just for now we're going to say it's minutes. I guess I should have wrote all that out, but you'll see that on your worksheet as you're working it. And by the way, these are all number 1 of each set. Okay? So now, we had here, we had 10 minutes, we were at 27 inches, not squared, we were at 10 minutes, we were at 27 inches, we backed off to 20 inches, so that means we should decrease our time substantially there. Okay? This guy's pretty simple. We're just going to multiply this through. 15 times 3 times x squared equals 15 times 5 times 31 squared. So, 15 times 5, I'm just going to write this out. It's going to be this times this divided by that. Doesn't make a difference. So, 15 times 5, that's one quantity, times 31 squared. So 15 times 5 times 31 squared. That is 72,075. That has to equal 15 times 3, okay, that's one quantity, times x squared. Okay, I guess I should do this. So, we're going to divide that by 15 times 3, okay, or 45. That's where I got that. 15 times 3 is 45. So 72,000, so on and so forth, divided by 45 is 1601.67, okay? And that equals x squared. So square root x squared, you get x, so we got to square root this side as well. So we square root that, and we come up with 40.02, and we were looking for source to film distance 2, so that is going to be in inches. Okay? So, nothing too terribly difficult, just cross multiplication. If you took the tech math class over the summer or have taken math before, college algebra, so on and so forth, these are just standard ratios. Okay? So, cross multiplication says this times this divided by that equals that, or this times this divided by that doesn't really make a difference. So, we jump over here, we would say this times this divided by that equals that. Okay? If you have an x squared in your answer, you have to square root it, because you can't have a squared in your answer. You're just looking for plain information like milliamps or minutes or a distance. Okay, and a distance is going to be squared in the calculation, but it's not going to be measured as 10 inches squared. Okay? So, nice Monday morning here. Should be pretty simple calculations for you guys to look at. Good luck and good scoring.